Hello everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105.
This video is all about the tutorial for the chapter 3. The chapter 3 is titled Network Protocols and Communication. So, more and more, it is networks that connect us. People communicate online from everywhere. Conversation in classrooms spill into instant messages, message chat sessions, and online debates continue at school. New services are being developed daily to take advantage of the network. So, the network is very important for us and nowadays. So, the people communicate online from everywhere. So, we usually more communicate into using social media, different social media apps. So we can communicate the people away from us using the social media, and the social media uses internet. So next, the communication fundamentals. A network can be as complex as devices connected across the internet. So, or as simple as two computers directly connected to one another with a single cable and anything in between. Network can vary in sizes. So, human communication. So, I will explain this one. So, the message, then the message source, the signal or the transmitter, then the transmission medium, then the signal, the receiver also, and the message destination. So the first one is the message source. It will be came from the uh, people. Like for example, this guy. It has a message for this guy. This one is for the source message source. Then what medium they use? It's like speaking or chatting or calling, and then this guy is the receiver, so this is the message destination. Then next is the rule establishment. Before communicating with one another, individuals must have used established rules or agreements to govern the conversation. So before starting a conversation, they need to have uh, rules for their conversation. uh, this Unidentified sender and receiver. So the sender should identify her receiver, and the receiver should identify the sender. Like for example, we need to, uh, let's say, we will call the person that we want to give a message. Then common language and grammar. So the language is very important. So you need to have one language only for you to easily understand each other. Speed and timing of delivery. So on how you present your message, confirmation or acknowledgement required. So is if it is the receiver understand what did you say. Message encoding. One of the first steps to sending a message is encoding. So encoding is like your typing or uh, your uh, your thoughts or what you call that. Encoding is a process of converting information to another acceptable form for transmission. So it's like uh, your message is being uh, compiled. So and then for the receiver to receive that, so that is the message encoding. So the message size. Another rule of communication is the size. When people communicate with each other, the messages that they said are usually broken into smaller pieces or sentences. So, when we are talking to someone and giving information, so we didn't say it all, like we was, so for the receiver to understand it. So it will be broken into pieces. So sentence by sentence, because if you uh, says it in many, so the receiver might not understand what you said. Message timing. There are the rules of engagement for message time. So it is for the two-person. When this diagram showed the two-person uh, calling. So if they talk in the same time, so they didn't understand each other. So they need to give each other chances to talk. It's like, for example, if she is talking, the boy is listening. If the boy is speaking, the girl will listen. So just like that. So the timing of their conversation. Then message delivery option. Uh, we will focus on this diagram. So the first is the unicast. So the unicast is the two people only. The source and the destination is one only. So she is speaking to one person only. Next one is the multicast. So it is for two people or more, but not all. So uh, the girl here are speaking to two person. So that is a multicast. Then the broadcast is for all. So again, it is a unicast is for only one, multicast is for two or more but not all, and then the broadcast is for all. Rules that govern communications. So a group of interrelated protocols necessary to perform a communication function is our protocol suite. Protocol suite are implemented by hosts and networking devices in software or hardware or both. So in this excuse me. So in this diagram, the protocol suite are a set of rules that work together to help solve a problem. Like for example, this one. Use a common language. So the first uh, rules that we need to have is common language. Oh, if uh, if you decided to speak in English, then speak in English, or in Tagalog, speak in Tagalog. So the for you to easily understand each other, then wait for your turn. So if it is talking, then you will listen. Then if I am talking, you will listen. Then, then signal when finished. So if you are finished, so so that the other uh, can know that you are done. Network protocol. So this one, the format structure of the communication pieces. So has a IP and data here. So I will send this message across the network using an IPv4 header. Then I can forward this message because I understand the IPv4 header. I can accept this message because I understand IPv4. So because they use one common language, uh, this man. So he uses the IPv4. So the router can forward the message because it can understand the IPv4. So it can receive this one, the message, because it can understand the IPv4. So that's simple. It's just like a communication of the human. Protocol interaction, the HTTP, TCP, IP, and Ethernet. So this one is the protocol stack. So the hypertext transfer protocol is an application protocol that governs the way of a web server and the web client interact. So it is between the web server and the web client interact. So the layer name is that application for the hyper uh, transfer protocol or the HTTP, and the TCP is the transport protocol that manages the individual conversation. So it manages the individual conversation. So that is the transport. And IP is the responsible for taking the formatted segments from TCP, encapsulating them into packets. So that is for the internet. So IP is the responsible for taking the it is responsible for the formatted segments from TCP. Then the next one is the Ethernet and the network access. So Ethernet, so it is a network access protocol that provides true primary function. So it has a primary function. So communication over a data link and the physical transmission of the network media. So the next is the open standards. Open standards encourage interoperability, competition, and innovation. They also guarantee that no single company's product can monopolize the market or have an unfair advantage over its competition. So open standards. So they have the standards that are um, they follow. So the IEEE, the IANA, or the Internet Assigned Numbers Authority, the ETF, the ICANN, E2, and the TIA. The Internet standards organizations are usually vendor-neutral, non-profit institutions established to develop and promote the concept of open standards. So it says here that it is a vendor-neutral, non-profit institution. So they promote the concept of the open standards. So they have here the Internet Society or the ISOC responsible for promoting the open standards. So this one is the responsible for promoting the open standards. Then the Architecture Board is responsible for overall management and development of Internet standards. Uh, if this one is responsible for promoting the open development and evolution. This one is manages all the development in the standard internet standards. So the next one is Internet Engineering Task Force. So this one. So these are the responsible for developing or updates and maintain internet and TCP IP technologies. And this one is Internet Research Task Force. So focus on long-term research related to the. So it's like they are the future. So they are continuing to research about their open standards. So they are preparing for the future. Then the Internet Corporation for Assigned Names and Numbers, based in the United States, coordinates IP addresses allocation, the management or domain of names, and assignment of either of other information used TCP. So the management of the domain names and assigned. So it's just like in their names. Then the Internet Assigned Numbers Authority responsible for overseeing and managing IP addresses allocation. So they are the responsible for overseeing the managing the IP address. The Electronics and Communications Standard Organization. Let's start with the IEEE or the Institution or the Institute of Electrical and Electronics Engineers. So this organization is organization of electrical engineering and electronics dedicated to advancing technological innovation and creating standard in a wide area of industries including power and energy and healthcare, telecommunication, and networking. So this organization is responsible for the electrical and electronics. So uh, they are also responsible for advancing uh, the the power and energy, healthcare, so something like that. Then Electronic Industries Alliance. So best known for its standard related to electrical wiring connectors. So the EIA is now the responsible for the wiring connectors, electrical wiring connectors, and 19-inch racks used to mount the networking equipment. Next one is Telecommunication Industry Association, responsible for developing communication standards in a variety of areas including radio equipment, cellular tower, voice over IP devices, satellite communications, and more. So they are the responsible for the radio equipment, the cellular towers, the voice over IP devices, and the satellite communication and board. So the next one is the International Telecommunication Union, telecommunication standardization sector. Uh, One of the largest and oldest communication standard organization. So it says here that ITU-3 is the largest and oldest organization, then defines a standard for video compression, internet protocol, television, and broadband communications such as digital subscriber line or the DSL. So they are the responsible for that. The benefits of using a layered model. So this one, assisting in protocol design because protocol that operates a specific layer have defined information. So these are the layered. So we have here the application presentation session, transport network data link, and the physical. So the TCP/IP protocols that are the for application presentation and session. So we have here the HTTP, DNS, DHCP, FTP. And for the transport, we have the TCP and the UDP. In the network, we have the IPv4, IPv6, ICMPv4, ICMPv6. In the data link and physical, we have the PPP, frame relay, and the Ethernet. So for the TCP/IP model, so the application presentation and session also have application. Then the transport, they have the transport. Network, they have the internet, and the data link and the physical, they have the network access. The OSI reference model. So I said it a while ago. So let's do one by. So the first one is the application. The application layer contains protocol used to process communication. So the application is for the to process the communication. Then the presentation is mm, provides for common presentation of data transferred between application layer services. The session is provide services to the presentation layer, organize its dialogue to manage data exchange. So in the session, it organizes the dialogue to manage the data exchange. So for them to easily understand each other, so the session organize their dialogue, and the transport divide services to segment, transfer, and reassemble the data for individual communication between the end devices. So it defines the segment, whether it is a segment, transfer, and reassemble the data for individual communication. Then the network is services provides services to exchange the individual pieces of data over the network between identified and devices. Uh, they are they provide services to exchange the individual pieces of data over the between the identified and devices. Next one is the data link. So the data link protocols describe methods for exchanging data frames between devices over a common media. So here, the data link describe it is for description of the methods for exchanging the data frames between the device over the common media. And then the physical is describe the mechanical, electrical, functional, and procedural means to activate, maintain, and deactivate physical connection for bit transmission to and from a network devices. So the physical is for the physical parts. So such as the physical connection, the electrical, the mechanical, the functional, and different use also for the maintenance and the deactivation of the physical connections. So this OSI model and TCP/IP model comparison. So they have here the OSI model and the TCP model. So the key similarities are in the transport and network layers. However, the two models differ in how they relate to the layers above and below each other. So it says here that their similarities are the applications for the and the transport and the network layer. So, but they differ in how they relate to the layers above and below each layer. So, even though they have the same, uh, they have similarities, but they differ on how they relate to layers above or below them. So, the message segmentation. So the segmentation is breaking communications into pieces. So from this one. So in theory, a single communication such as music, video, or email messages could be sent across. So it's like segmenting a message. So if message were actually transmitted in a loose manner, it would be made to other devices. So the protocol data. So the data. We have the data here, the general term for the PDU used at the application layer. Then it is the data is using in the application layer. So this and then the segment is transport layer PDU. Then the packet is layer network layer PDU. The frame is the data link layer PDU. And the bits are a physical layer PDU used when physically transmitting over the medium. So this one, encapsulation. When sending messages on a network, the encapsulation power from top to bottom. So it says here that it is from top to bottom. So it works from top to bottom. So that is the encapsulation. So the encapsulation is the process is the reverse of the receiving host and is known as decapsulation. This one moves up the stack and user. So if the encapsulation moves from top to bottom, the encapsulation is moved from bottom to top. So network addresses, network layer source and destination responsible for delivering the IP packet from the original source. So the network layer source and destination. So it is the responsible for delivering the IP packets from the original source to their destination. The data link layer source and destination addresses. So they are the responsible for delivering the data link frame from one network interface to another. So uh, this one it is the responsible for delivering the data link frame from NIC to another NIC on the same network. So the source IP address is the address of sending device. So uh, the source IP address is the IP address of the one that who will send a message. Then the destination IP address is the IP address of the receiving device. So the destination IP address is the one that the IP address of the one who will receive the data who sent by the source IP address. So devices on the same network. So network portion, the leftmost part of the network address that indicate which network the IP address is a member. All devices on the same network will have the same network portion of the address. So this one is the network. So the leftmost part of the address that indicates the network, the IP address is a member. Then the host portion is the remaining part of the address that identifies a specific device on the network. So the network is the leftmost part and the host portion is the remaining part of the address. So data networks are system of and devices, intermediary devices, and media connecting from them. So this chapter is that it says that the data networks are the system for the end devices, which are the computers, laptops, cell phones, different gadgets for sure. Intermediary devices are uh, routers, wireless routers. For communication to occur, these devices must know how to communicate. But first, they must know how to communicate. So, I said also a while ago that it needs to be a rule for them to easily each other. So that's all for this video. Thank you for watching.